everyone, and thank you for tuning into LearnCast. My name is Jenny, and today we will be discussing the components of experimental research design and statistical methods in terms of AP Psychology. Please keep in mind that the Research Methods unit of AP Psychology is a common topic on college board exams, so it's important that we understand the foundational basics of these elements. To start off, we will be talking about experimental research designs. There are three characteristics of the scientific attitude: curiosity, skepticism, and humility. Curiosity refers to asking questions about topics such as the human behavior or mental processes and wanting to know more. Skepticism involves doubting and questioning ideas, results, and theories in AP Psychology, and humility is just the accepting of responsibility when one is wrong. This attitude should be carried out during conduction of the scientific method and beyond the research itself. Scientists are continuing to learn new things about the human psyche because of the attitude they hold toward science. Now, let's review some of psychology's definitions in experimental design. An experiment is a research method in which an investigator manipulates or changes one or more variables to observe the effect on some behavior or mental process. For the purposes of today's conversation, let's have our scientific question be: does caffeine improve test performance? In order for a study to be considered an experiment, it should include the following components. An operational definition. This is a statement of the procedure or operations used to define research variables. The importance of this aspect is that these statements are very specific. We want to know exactly what the investigator is looking for. So for our example, does caffeine improve test scores or performance? We would need to operationally define what we mean by caffeine. Are we talking about the participant drinking Coke, Red Bull, a cup of coffee, or taking caffeine pills? We need to define that. And does it impact test performance? How are we going to measure that? On what type of scale or test are we using? These have to be specifically defined before beginning an experiment. And what are these aspects we are labeling? They're the independent and dependent variables. An independent variable is what is being manipulated or changed by the experimenter to observe its effects. In our example, the independent variable would be what we operationally defined as caffeine. Let's go with coffee. The addition, amount, or lack of coffee could be a way this variable is changed across test groups. The experimental group would be the participants who are given the coffee. This is where the independent variable is applied. And the control group would be the participants who don't receive any coffee. They're treated the same as the experimental group, except the independent variable is not applied. The dependent variable is the effects or changes that occur in relation to the independent variable. So this would be whether or not test performance actually improved due to the intake of coffee. Remember, how we measure this test performance needs to be operationally defined in order for the results to show reliable data. And speaking of reliable data, we must keep in mind that experiments need to be replicable. This replication refers to the ability to repeat a research study with different participants in different situations. In our example, this could be most applied across different trials of the experiment. However, certain factors of the experiment can be changed and replicated, such as the type of caffeine. That would be a change in situation. Before we close up on our experimental research discussion, there are two more variables investigators need to consider in all experiments: extraneous and confounding variables. The extraneous variables are undesirable factors other than the independent variable that might produce an effect in an experiment. This is something that cannot be controlled by the investigator. Let's say the day of testing, the testing environment wasn't suitable for the experiment. The AC broke, so the room became hot and people had to open up their testing room doors to let the air circulate, which gave way to lots of other sounds outside of the testing room. These uncontrolled and unplanned variables can produce an outcome in the data results. Confounding variables are two variables linked together in a way that makes it difficult to sort out their independent effects. This can't be controlled by the experimenter either. An example of a confounding variable when looking at whether caffeine improves test scores could be the participant's intelligence and work ethic. Some people might do better on performance regardless of the caffeine, which makes it difficult to separate the independent results. So that wraps up our first topic about experimental research designs. Now let's shift our focus to statistical methods in AP Psychology. Before we begin our dive into the basics, let's review some definitions. Statistics. This is the use of mathematics to organize, summarize, and interpret numerical data. To summarize the distribution of scores through a single value, we look at the central tendencies. There are three measures of central tendency: mean, median, and mode. Mean is the arithmetic average of the scores. Median is the score that falls in the center of distribution, and mode is the score that occurs most frequently. Statistics and AP psychology generally looks at the data on a normal curve or distribution. This can be visualized as a symmetrical bell-shaped curve. This curve describes the distribution in many types of data such as height, IQ, etc. Most scores will fall near the mean, which is near the center and higher part of the curve, and fewer near the extremes. Variance is how much scores in a set of data vary from the mean, and standard deviation, which is the index of the amount of variability in a set of data, is calculated by taking the square root of the variance. It is basically how much difference from the mean is there in one standard deviation. Let's use an example to help us get a better understanding. Alright, a distribution of aptitude test scores forms a normal curve with a mean of 100 and a standard deviation of 15. It may be helpful to pull up a picture of a standard deviation on a normal curve, but if you can't, that's totally okay. Let's visualize it together. Imagine a symmetrical bell-shaped curve. In the center, where the curve peaks, is where the average, 100, is located. This is where the standard deviation is at 0%. Now, think about sections that are roughly 34% to the left and right of that center line. The area between the two lines we just visualized creates one standard deviation. Thank you for joining me for our review of the experimental research designs and statistical methods in AP Psychology. Be sure to follow us on Spotify, subscribe to our YouTube channel, and check out our website to stay up to date with the latest releases. Until next time, listen, learn, repeat.